Hi, welcome to the video for the molecular and empirical formula notes and the beginning of the lab. This is Miss DeLuca, and you're going to need these three papers. The half sheet, the one that says examples on the top, and then also the molecular formula calculations lab. So we're going to start with the half sheet. So empirical and molecular formulas are formulas that take two different forms. Every formula that you've seen up until this point has been a molecular formula. So we're going to start with that one. Okay, so the molecular formula is, you can think of it like an unreduced fraction. So an example would be 5/10, or 3/6, 500 1,000ths, 251 thousandths, anything like that. These are the formulas that have the actual number of atoms. In a chemical compound. So an important difference does not apply to things like H2 or O2. Those are not chemical compounds. Those are just molecules of an element. All right, so these are the formulas that tell you exactly how many atoms are in one molecule of a chemical compound. These are the most common. And they can be used for a variety of purposes. Now the empirical formula is, you can think of it like the reduced fraction. Okay, it cannot get any smaller. 1/2 or 3/4 or 1/5. So like if you had 5/10, that would be 1/2. So the 5/10 would be the molecular formula, and the 1/2 would be the empirical formula. Right? This formula is the most reduced ratio of elements in a chemical compound. So for instance, if you had a chemical formula, I don't think this is a real chemical, but I'm just going to do it for funsies. So let's take lithium. So we have 8 lithiums and then 16 chlorines. This would be one molecule of something. Then the empirical formula would be, so you figure out the lowest common denominator. We'll put that up here. The lowest common denominator. So we can divide 16 by 8 and 8 by 8. So we'll divide these. And then that makes 1 lithium. And then you would have 2 chlorine atoms. This would be the empirical formula, because it's the reduced fraction. This one would be the molecular formula. Right? Empirical formulas are used a lot in labels and for easier math. And you can use an empirical formula to find the molecular formula by doing some math. Okay? So the most important thing for you to remember is that empirical is the reduced and the molecular is the actual. Okay? So we're going to take this and we're going to set this aside. It's going to be flapped on top of the next notes that we're going to do, which includes some practice problems and then some information that you will use on your lab. All right, so the instructions for the first one say find the empirical formula by reducing the molecular formula to its lowest common denominator. So C6H12O6. Okay, so we have a 6, a 12, and a 6. Just so happens that 12 is divisible by 6, so we'll divide this by 6, by 6, by 6. And the empirical formula that we get is C, and it would be a 1, but we don't have to write the 1. And then H2, and then an O1, but we don't need to write the 1s. Okay, so for our next one, galactose. Oh my goodness, it's the exact same chemical formula as glucose. It's like we lied to you in biology or something. These are all carbohydrates, by the way. That you should have remembered, maybe, from the first part of your freshman year. So C6H12O6, still divisible by 6, so it's going to be CH2O. This one actually should not be here, it should be up here. So from biology, you may or may not remember that when these molecules bind together, they do it through a process called dehydration synthesis. Dehydration synthesis means the molecules connect together, but it leaves one molecule of water out. So we're going to pretend like this water molecule has added back in. So that would make this a 24, and that would make this a 12. So it's C12H24O12. And then if we reduce that down, so 12, 24, 12. 24 is divisible by 12. Goes in it twice. So we'll have 12 divided by 12, which is 1. 24 divided by 12, which is 2. And then 12 divided by 12, which is 1. So same formula. All right, down here, this is fructose, which is also a monomer. So it is C6H12O6. See, the empirical formula is CH2O. And down here, this is another one formed by dehydration synthesis. Sucrose is your everyday table sugar. So we have a 12, and we're going to add this 2 back into this. So this is a 24. And then we're going to add this O back here, which makes this a 12. So we have 12, 24, 12. So 12 divided by 12 is 1. 24 divided by 12 is 2. 12 divided by 12 is 1. So CH2O. Holy cow. All those different sugars have the exact same empirical formula. You cannot use the empirical formula to determine what something is. Lots of chemicals can have the same empirical formula, but different molecular formulas. So even though glucose and sucrose have the same empirical formula, they have very different molecular formulas. So the carbohydrate ratio, so we have 1 carbon to 2 hydrogen to 1 oxygen. So it is a 1-to-1 ratio, which is literally, if you look up on the wall at the carbohydrate poster, it has ratio 1 to 2 to 1 because almost all sugars are a 1-to-2-1 ratio of carbon, hydrogen, and oxygen. Okay? Haha, see, you would use it again. Just didn't think it would be today. All right, the next part, I'm going to label and use highlighters. So I have a lighter color and a darker color. You can use a marker or pen, something. I like color, okay? So this one says to label each formula as either empirical or molecular. I'm going to use my highlighter and I'm going to highlight the molecular yellow and the empirical blue. Okay, so OH and H2O2. Which one of these is the reduced version? Reduced version. See if you can pick it out for yourself before I tell you the answer. Can you do it? Do you know? Take a guess. The reduced version, or the empirical, is the OH. So that would make the non-reduced version H2O2. Okay? Empirical, molecular. All right? I would like for you to pause the video and then try to figure out the rest of them. And once you've done that, you can unpause the video and see if you are correct. Okay, hopefully you paused and you tried, and if you didn't, you cheater, go try it for yourself. All right, so the answers here are going to be, this is the non-reduced, so this is molecular, this is the reduced, so this is the empirical. NaCl is both it's the molecular and the empirical, because it cannot be reduced any further, and it also is the exact number of atoms. So right here, S2O2 and SO. SO is the reduced version, so this is the empirical. So that makes S2O2 the molecular. So out of these three, so we have C4H8, CH2, and C2H4. The CH2 is the reduced version of both of these, which makes this the empirical, which means these two are molecular. And then this bottom one, we have CH2O, C5H10O5, and C2H4O2. This is the reduced version of the other two, so that is the empirical and the molecular and molecular. And interestingly, this is actually acetic acid, which is not a sugar, but it does have the same empirical formula as all of these sugars up here. So again, we can't identify the substance based on just the empirical formula. You need to have the molecular formula before you can determine the identity of a chemical compound. All right, and this one's kind of both. So I'm going to highlight those yellow, and then I'm going to do my empiricals blue. So this one's kind of both. And then blue, blue, blue. Here we go. Okay. Okay. So the last bit of notes that we're going to take are about how to use your understanding of moles. That was from a previous class, which you should have notes on if you forget. And then use that understanding to do some really simple math to find the molecular formula of something. All right. So you can use the molar mass and the empirical formula to figure out the molecular formula of any chemical compound. Okay, I actually should have done this in blue. The empirical formula. Okay, so we know how to figure out the molar mass of something. And if you don't remember that, we'll look back to your notes from the last time that we did chemistry. And I'm going to tell you that this is very easy. Please don't get discouraged, okay? So in order to find a molecular formula, we need to find a multiplier. It's going to be a whole number, not a decimal, of what we need to multiply this times that multiplier to get your molecular formula. Again, it has to be a whole number. In the lab that you are going to do, weighing something exactly is very difficult. So you're going to need to be able to round up to the whole number for your multiplier. All right, so our problem says you have a substance with a molar mass of 200.04 grams per mole. The empirical formula is CF2. Find the molecular formula, okay? So to find the multiplier, you're going to do two things. You're going to take the molar mass of the molecular formula. Sorry, it's really hard for me to talk and write at the same time. And you're going to divide that by the molar mass of the empirical formula. But how do we do that, Mr. Luca? I don't remember. Okay. This one is easy. This was given to you in the problem. Right here. Molar mass. So you just need to copy that from the problem. Okay, and then the molar mass of the empirical formula is going to be using this plus some math to find this, okay? So to find the molar mass of CF2, so we have C and then an F and an F, you need to find the molar mass of the element. And you do that by looking at your periodic table, looking at the atomic mass, and adding a G to the end. So for carbon, it is 12.01 atomic mass, so its molar mass is 12.101 grams. And we have two F's because it's CF2. So if you look at the periodic table, fluorine is 12.998. Nope, 18.998. And if you round that up, we're going to say it's 19.0 grams. And we need two of those. And then all you have to do is add those together. And when you add those together, you should get 50.01 grams per mole. And that is the molar mass of this empirical formula. So now you just do a little bit of division. Our first number is 200.04 grams per mole. And I'm going to divide that by what I just figured out, which is 50.01 grams per mole. And when you divide those, the answer you should get is 4. So 4 is your multiplier. Okay, so we'll take CF2 and we have to multiply each thing by 4. So 1 times 4 is 4. So it's going to be C4. And then 2 times 4 is 8. So it will be F8. And this is your actual answer. The molecular formula is C4F8. Okay? Your periodic table is going to be important. And remember, this has to be a whole number. All right. So after you finish this, I would like for you to trim it, and you're going to tape it onto page 76. 78. Page 78. Okay? So on page 78, so sorry. Here we go. You're going to trim this out. Keep it on page 78. And then you're going to take this and kind of flap it over the top so you have the notes and the definitions on the same page. Okay? Then on the page across from it, which should be page 77, this is where your lab sheet is going to go when you're finished. And after I grade them. So your lab sheet will go over on this side. Okay? So you're going to take your lab sheet. Make sure you have your notes and stuff with you. You're going to write your name on it so we can get credit for it. And you are going to go over to the samples. There should be a 4. There's 4 samples. And you're going to record the empirical formula, which is on a note card over at the table. Then you're going to use the scales to measure the grams per mole of the given substance. I have measured out exactly 1 mole of each of the substances, as close to exactly as I could get. Then you're going to do this math to figure out the multiplier, which should be a whole number. You'll write that here. Then you will tell me the molecular formula, and then you need to figure out the percent composition by mass. If you don't remember percent composition, you need to figure out the mass, which would be this right here, and you're just going to figure out the percent of each atom. So you need to know how much for instance, if it was carbon and fluorine, how much the carbon should weigh per mole, how much the fluorine should weigh. Then that percentage, you find the part of the whole. So you take the small and divide the small by the big, which is the total, the whole. And then you times that times 100, and that's how you get a percent. And then, so if nitrogen was 40%, then whatever the other one would be 60%. Okay? There's all this space down here to show me your work, because you need to show me your work. And on the back here, there are 4 analysis questions for you to answer. Once you are done with this, you're going to bring it to me so I can check it, and then you can have the rest of the period to work on the practice problems. You can work with a partner to figure them out, but I do need both of you to complete a worksheet. And those worksheets will be due to me on Wednesday. All right? Good luck and have fun.